milling on the ends now, you're going to have the part sticking out of the vise. If you have the end of the part sticking past the vise, that way your cutter does not hit the vise. Now the end mill we're using today is a high-speed steel end mill. It has 4 flutes. The end mill goes up inside the collet. Now be careful, these end mills are very sharp. So you want that to be up in the collet as far as you can be without getting the flute of the tool inside the collet. You want to keep your cutting tool as short as you can. This collet has that taper on it with the groove. This is the R8 taper collet. Once again, line up the key to the spindle. So now our end mill is in the machine. We have to figure out the speed for this cutter. So if you look on your chart, it'll say mild steel. That's still the material we're working with. Our cutter is now high-speed steel. So the cutting speed for a high-speed steel cutter in mild steel is 80. And if you look at the formula, it says 80 times 4 divided by diameter. The diameter of the cutter you have to measure, and this cutter that we're using today is 3/4 inch. So if you get out your calculators and you calculate 80 times 4, divided by 0.75 tells you that your cutting speed or your RPM would be 425. So now 425 will be on the low setting, so we'll have to put the gearbox into low, and we'll start the machine and we can dial down the variable speed. So we're going to put it in low now. Spindle start. We got to increase on the low side. So 425 is what we're looking for on the low speed. So just make sure every time you change a cutter that you have to use the proper cutting speeds for each tool. So now just like we did when we face milled, we touch the surface of the part with the cutter. Well, now we're working on the end of the part. So we have to raise the table up quite a ways. I know it's very tempting to just unclamp your spindle and pull your spindle out of the machine or pull the quill down. The problem with that is it's not very strong. You want to keep everything as short as you can. When doing this process, it's very important not to climb cut. You want to do conventional milling. When you climb cut, if you just kind of watch how this cutter rotates. As this cutter rotates in the forward direction, you got to think about which way you're going to feed. If I feed the material into the cutter in this direction, it's actually going to want to climb onto the material, and the cutter will try to cut more than you want it to. So you actually want to start on the side nearest you. So as the cutter rotates, you're feeding it into the cutter. And the cutter will be pushing against the material rather than trying to grab more material. All right, so I'm going to start my machine. I'm going to feed over on the x-axis just until it touches. So I just touched the end of it. Now when we were doing our face milling, we used this dial. We were zeroing out this dial. Now we're going to be using our readout or our digital display. So on our digital display, it's keeping track of our X, our Y, and our Z. Remember, Z on this one is the spindle in and out. We're not using that. That's still all the way up and tight. What we're going to be using now is we're going to be moving in the X. We're actually measuring with the X-axis. So right now I just touched it in the X-axis, so I want to zero that. Now every display is different. Please see your instructor before you do this. But on this one, F4 will perform X0 is what it says. So if I push F4, then I have a choice. I can either do it or hit escape. Escape will take you back to that original page. So you got to do F4 and then hit plus. When you hit the plus, it'll actually do the setting. And you'll see now that X switched to 0. So now that we know where we're starting at 0. Let's just say we want to take 10 thousandths off for right now. 10 thousandths when you're taking off the end of a part on the whole depth of the tool like that is enough. So we're going to go 0.01. When we talk here in the machine shop, we talk about the third decimal place. So you got to kind of look at 3 decimal places. When I say 10 thousandths, that's what I'm talking about. 10 thousandths of an inch. Or 1/100th of an inch. But we always express everything in thousandths because the tools we use and the blueprints that we read are almost always in the third decimal place. Now we're going to be feeding with the y-axis, so I want to make sure I lock X. I don't want X to be moving this way while I'm cutting this way. So you clamp X, and you're going to be feeding with Y now. So I'm going to start my machine, low gear. High-speed cutting tools like lubrication, and I have some here that's already pre-mixed. It's coolant, so we're going to use this coolant on the cutter. It doesn't take a lot, just a little bit. It prevents the tool from overheating and it helps the cutting process. So I'm just slowly feeding across the end of this part. Once again, we're just hand feeding. We could calculate the feed, but we're just going to hand feed for right now. If I was programming this machine, I would then calculate it and program it in there. So that was our first pass of 10 thousandths. I'm going to take one more light cut. I want to take a finish pass, and then I'm going to flip my part over and take the rest of the material off the other side. So I'm already 10 thousandths. I'm going to take another 5. So 10 plus 5 is 15. So I'm going to go to 15 on my display. I'm going to reclamp my X, start my spindle, and take a real light finish cut. I'm going to unclamp X and move it away from the cutter. I'm going to move it that way. I'm going to bring it back towards me so I'm not working by the cutter. That cutter is very sharp. You don't want to bump your knuckles or your fingers into it. I'm going to take my part out now, deburr the end, and flip it over. Now once again, we're going to have burrs all the way around the outside of this part, so we got to deburr this part. Clean out your vise. Now these chips from the end mill are going to be very slivery. They're very sharp little chips, and they'll poke right into your skin like slivers, so don't handle them with your hands. Just brush them out with the brush. Make sure your parallels are clean. If your parallels are clean and your part is clean, now you take the side you just machined and put it away from the cutter. You want to machine the other end. Put your part back in the vise. Make sure it's sticking out past the end of the vise, and you can tighten it. Right now this part is rough length. I think it's down to, it's just under 4 1/4. It measures about 4 3/16. So let's just say I'm going to try to hit the target size of 4 1/8. I know I have about a 1/16 of stock, which is 0.0625 as far as the decimal is. So I know I can take off some more of this material. So I'm just going to touch the part again, and I'm going to zero out the readout. Just touch the end of your part. I'm going to zero X, push F4, plus. So I zeroed out my display. I'm going to go over another 10 thousandths. I know I got about 60 thousandths to go, so I can safely take 10. I'm going to clamp it, and I'm going to zero X again. So when I take this cut, I know where I'm at. So F4 plus. So go ahead and feed across the end. We're just hand feeding again. And once you cut across the end now, you can measure your part. When you measure the part, your readout is reading 0 on X. So take a 4 to 5 inch micrometer. Let's measure the end of the part now and see how long it is. According to the micrometer, which is more precise than my ruler, it says it's 4 inches, 186 thousandths. 4.186 minus 4.125 tells me I have 61 thousandths to go. So 0.061 now is how much further I got to go to get to my size. Right now I'm starting at 0, so I have to go 61 thousandths. So I'm going to start my machine. I'm going to come back to the start point where I was starting my cuts. You could probably take 20 thousandths every pass. Remember, we're going to stop when we get to 61. That should be our finished size. So our first pass will be 20, 0.02. I know I can take another pass of 0.02. So 0.02 plus 0.02 is 0.04. So I can go another, if I go another 20, I'll be at 60 thousandths. That would take me right to size, and I wouldn't have any stock for a finish pass. So I'm going to go to 0.055. After this pass, I should have about 5 to 6 thousandths left to go, and that'll be perfect for a finished cut. Let's just check where we're at here. Make sure we're not going to go too far. After the cutter stops rotating, then you can go in for your measurement. You shouldn't have your hands or measuring tools anywhere near a rotating cutter. According to my micrometer, I am at 1 inch 31, so I have exactly 6 thousandths to go. And that works out exactly with my display. So I have to go to 0.061. First I gotta go back to the start point of my cut. I'm gonna unclamp X, move it over to 0.061. Reclamp X, and take your last feed rate here for your last pass. Okay, you can unclamp X. Let's move it away from the cutter. Let's bring it out here so we don't bump our hands into the sharp cutter. Well, let's make sure it's the right size before we remove the part. If you take the part out and put it back in and have a little bit more to machine off, it's not as accurate as if it's already in there. So just measure it while it's in the machine. And it's measuring a 1/2 thousandth small, so that's pretty good. That's within the tolerance that I was trying to hold. I'm looking for ±1.